Suppose that money is worth 8% compounded quarterly. How long before a scheduled payment of $6,000 will $5,000 be an equivalent payment? Here, our formula to find the number of compound periods should apply, since we're trying to find a term. Let's go ahead and start filling in some of the values that we have. We're going to be comparing our payment of $6,000 to a payment of $5,000. So we'll take $6,000 to be the future value and $5,000 to be the present or principal amount. In our denominator, let's take ln of 1 plus I. Here we'll take the rate of 8% compounded quarterly. So next we want to start working on getting that into our calculator. Let's take 6,000 and divide by 5,000. Hitting the equals button, we can then apply the logarithm to that value. So this 0.18 is going to be the value that's inside of the numerator of our large fraction. We need to divide this by bracket 1 plus 0.08 divided by 4. Let's close that bracket and then apply the logarithm to this value. This should be the denominator of our large fraction. Let's go ahead and hit the equals button. Now we've divided the two values, and this is our overall final value for n. So we see that n should be about 9.2 compounding periods. But we can't have 0.2 of a compounding period, so let's go ahead and round this up so that n is equal to 10. Next, we know that n is equal to t times f. So t times f must be equivalent to 10. Our goal here is to determine the term, or how many years. So let's input our frequency number of 4, and then in order for us to solve for the number of years, we're going to take 10 and divide by 4. 10 divided by 4 is 2.5, so we can conclude that after a span of 2.5 years at a rate of 8% compounded quarterly, a payment of $5,000 becomes equivalent to a payment of $6,000.